So now that we've talked about polygons a little bit, we're going to talk about measuring polygons. We've talked about counting sides, but now we're going to start talking about area and perimeter. What's the difference? Yeah.
Area is stuff inside, perimeter is from outside.
Okay, good. I'm going to break your question a little, or your comments a little more. I agree that area is what's on the inside. Is that what perimeter means? No. So what's perimeter? Let's be precise in our language.
Like added, that's added total of all the sides.
Perfect. Added total of all the sides. If I take one length of a side and another length of a side and another length of a side, and I add them all up. So A, B, C, and D. The perimeter is A plus B plus C plus D. And that's true for any shape. I just add up the sides. But for area, it depends on the shape. Most of our formulas started with the idea of a rectangle. How do I find the area of a rectangle? Length times width. In other words, if I take this length and this width and I multiply them together, I get the area. So let's say this is 10 and this is 3. I can say that the area is 10 times 3 is 30 square units. Agreed? Now, what if I were to slice this shape in half? How do I find out how big this is? Yeah, Wade. Okay. Now, is that always true? Because now we made a triangle. And so that means that if I have this length and this width, that no matter where I draw that triangle, it's the same size. Is that true? Do blue and green have the same size? They do. Blue's easy to see, right? Because whatever's on the blue is also on the white. They offset, they're exactly half. I can show you that green is also exactly half by drawing a line straight down. And it turns out that this is half of this rectangle I've created, and the other half is outside here. And this is half of the rectangle I've created over here. And so these two add up to the same as these two. So isn't that kind of interesting that you can go anywhere up to here and come down to there, and this red one will be exactly half of the rectangle? What about a parallelogram? What's the formula for that? Length times width again. So if that's true,
Spoiler alert, it's not.
what's what I got going on here? So if this works on my screen here for people at home. A little higher here. Can you guys sort of see that this is a mess? Can you see that this is a rectangle? Okay. And if I tilt it a little bit, it becomes a parallelogram. Agreed? And if I keep tilting it, does it still have the same area as of that original rectangle? I mean, at some point it pinches out to nothing, right? So it must be getting smaller as an area. But the length and the width are staying the same. So it can't be length times width. There has to be something else going on. And it turns out it comes from this idea of rectangles. If I were to take that side and lop that triangle off and bring it over here, it would exactly fill this in to be a rectangle, which would be still the length long, but it's not W high, is it? It's this height. the width across the opening. So usually we say it's base times height. And the trick here is that base has to be perpendicular to height. They must make a 90-degree angle. If they're not, you can't do it. And the same is true of a triangle. If I want to find the area of a triangle, I have to do the base times that perpendicular height and then divide by 2. Any questions on these so far? This should be somewhat refreshing knowledge rather than new knowledge. So if we go to the back here, let's take a look at number 6 here. Find the perimeter of triangle ABC. Here's A, here's B, here's C. So I want to find that green length, this blue length, and this red length all together. Which one's the easiest? Blue, green, or red? Blue's easy, right? Why?
It's a straight line. Or, sorry, no, it's on the coordinate plane.
Good. It's on the axes, right? It's parallel to an axis. It's horizontal. And so this is really a one-dimensional thing. I'm going to describe AC, which is the length from A to C. And because it's just one-dimensional, there's no slanted up or slanted down, I can actually use my A plus B formula. Remember this? A minus C, absolute value. So in this case, I'd say absolute value of -4 minus 2. Why did I choose the X's and not the Y's? Because the Y's are the same, right? That's the whole point, is with the Y's the same, all I care about is the X's. So this becomes this absolute value of -6, which is 6. What about the green side, AB? Yes, sir. 3? How'd you get 3? You're right. It does go up by 3. Oh, but wait, this time the Y value changes by 2. If only we had a formula for finding the distance. What was your homework last night? Distance formula. Remember that? How many of you have memorized the distance formula? And that's exactly what this is for. This is called the distance formula. That's exactly what this is for finding sides that are not horizontal or vertical. So I could say that this is the square root of -4 minus -1 squared plus 3 minus 5 squared. What's -4 plus 1? Good. -3 squared. What's 3 minus -2? -5? What about BC? It is, isn't it? They're both 2 and 3. They're the congruent triangles. They're the same size triangle. So their hypotenuse will be the same as well. This will be the square root of 13 as well. Now, it asks for the perimeter. So now I'm going to say that the perimeter is equal to AC plus AB plus BC, oops. Which will equal 6 plus 2 times root 13. That number is in a precise form. Right now, we're not playing with that. So what I'd like you to do is find that value approximately. Use your phone or a calculator and get a decimal approximation for it. 6 plus 13 square rooted times 2 equals. And let's just leave it as to the nearest hundredth. Put a little squiggly equal sign there to show it's not exact. Would you please do the same thing with number 7, except this time, of course, it's a quadrilateral. Go. All right. Can I have your attention, please? How many got what I got here? If we're rounding to the nearest 100th, 2 decimal places, what would you call this? 24.65. We all agree with that? Are you guys aware that I post answer keys on Canvas? Would you please go to your Canvas and everybody look for the day 6 homework? I'm sorry? Go to Canvas. Is this the right answer? 24.64.
When you round up from 0.6,
Why? Isn't 0.32 plus 0.32 0.64?
I calculated like
I'm pointing out an issue here. What do you guys notice? This is not what's on the answer key, is it? First of all, can everybody please go to the answer key? Go to Canvas, go to geometry, go to the home screen, go down to day 5, no, day 6, right? Day 6, and make sure you know how to find the answer key for day 6. What? 6.5 is what the homework says. The answer key. What do you mean I rounded up? What? Hold on, 1 second. What do you mean I round up? Because I see up there I've got 6 plus 6.324. Doesn't this round to 6.32? So that's why it was 6.32. And if I add 2 3 2s, I get 6.4. You too. Here's the thing. Please listen. If I round off this red number, 6.32455, and I round it off early in the game, like I did on this screen I'm showing you right now, I've lost some detail. And if I do that a couple of times, like I've done here twice for the 2 red 6.32s, in the end, I lose some detail. I suggest one of 2 things. 1, in general, try not to round off until the very, very end. So in other words, I should have left this as square root of 40 and square root of 40. So now I've got 12 plus how many square roots of 40? 2. So this answer, we'll end up cleaning this up later. Please listen, guys. Folks, I've got maybe 2 more minutes. You'll have the rest of the period yourself. So give me your attention for now. We will learn how to simplify this, but this is accurate. It's just not simplified. And if I take my calculator now and add that up as it is, do I get the right answer? I'm going to start with the complicated part. So 40 square, I'm going to take 40, take the square root of that, times 2, and then add 12 to that. And I get 24.6 what? 24.65 now. Right? Because this 9 is going to make that 4 round up. That's what I want. Now, in the event that you can't do that, for some reason you can't bring it all the way to the end like this, you don't round off to the nearest hundredths early on. If you wanted to carry that as 6.3246. Carry a couple extra decimals. And then if you had added them up, it would have worked out to round correctly. If you're ending up in hundredths, you can't round off in hundredths early on. You'll lose precision. So carry extra decimals. Okay, you have the rest of the period to finish up this worksheet. Please show your work nicely as best you can. This is your homework.